Hello, this is David Shreeve, Algebra 2 instructor with Florida Virtual School. We're going to be looking at some piecewise functions. This is only in the honors version of the course. I've set a couple up here. This one on the left might be a little more challenging than the one on the right, but basically we're graphing all three of these functions, but only portions of these functions are going to show up on our final graph. So what you'll notice is I'm going to kind of separate my coordinate plane. I've got my coordinate planes set out here. Had a few students ask if they were going to use graph paper in this unit, and this would be one chance to use your graph paper. So the first one here is actually part of the group of functions we're studying in this unit, which is a quadratic. Now this one is in general form for us, so we can get quite a bit of information from just looking at this one in general form. We know when it's in general form, our vertex is just that h and k value, which is in this case it's going to be 1, -4. So I know I've got a vertex here at 1, -4. And if you'll notice here, part of the restriction on we're only graphing this function on the coordinate plane where x is less than or equal to 1. So a lot of times what I'll do is go in and kind of separate my graph out so I'll know where to stop with certain lines and things of that nature. On this one, if we're looking at x is less than or equal to 1, well, my positive 1, of course, is right here. So I'm just going to make a small notation here. A lot of times you can just write really lightly, and you'll be able to kind of erase if you need to after you're finished with the graph. So you can probably hardly even see that on the recording, but I just made a little light line there just so I know exactly where that value of 1, that x value of 1 is, because this quadratic is only going to be over here to the left side of that vertical boundary that I've drawn there. So the vertex is at 1, -4. I'm going to try to separate these graphs into different colors as well for us. So I'm going to go to 1 and all the way down here to -1, 2, 3, 4. Now I have to decide if I want to make an open circle or a closed circle. In this case, we have an or equal to 1. So this point is going to be on the graph. If that were to just say less than 1, I would have made an open circle right there on the graph. All right, so I know that's my vertex. So let's go ahead and we need to find several other values here. I'm just going to plug in. Remember, we're only graphing the portion to the left, so I'm not really going to bother plugging in values on the right, such as 2 and 3 and 4. I'm only going to worry about values over here to the left. So starting out with 0, and I'll work this first one out, and the rest we'll kind of calculate quickly in our heads. So if I'm plugging a 0 in for x, that would be 0 minus 1, that's -1. This one's tricky. You got to be careful about this negative value outside. But -1 squared is +1. But keep in mind you had that negative value outside of the parentheses where you plugged that in. So that negative will apply to that, making it a -1 minus 4, which is -5. Alright, so my next point here, if I use a 0 for x, my y value is -5. Alright, so 0, -5 is right here. Let's go ahead and, like I said, I'll just kind of quickly calculate these out. You do want to, of course, make all the calculations specific, but when I plug in a -1 for x, I'll have -1 minus 1, which is -2. -2 squared is a +4, but I have to apply the negative here. So it'll be -4 minus 4. So when I plug in -1 for x, I'm going to get -8. So 1, 2, 3, 4, 5, 6, 7, 8. I'll go ahead and mark that point. So this portion of the graph is going to look something like that. Now keep in mind this x value of +1 is also the equation of our axis of symmetry. So if you did wonder what the other part of the graph was, it is a reflection over that axis of symmetry. In other words, there'll be a point here, there'll be a point here. I'm just reflecting these points over that axis of symmetry. But as I said, we're not going to be graphing that portion of the graph, because once we go greater than 1 on x, we've got a completely different function that we're going to be graphing. Alright, so in this case, the next function is between these values greater than 1 and less than or equal to 4. So just to kind of make a little sketch of the boundary again, I'm going to move over here 1, 2, 3, 4. So where I'm going to have my next boundary. And as I said, I'm making those very light. The boundaries are not part of our graph, okay? So in this case, 3x is, or 3x minus 7, but we're only going to graph the portion that's right between here, okay? So to graph that line, I know -7 is my y-intercept. That's 1, 2, 3, 4, 5, 6, 7. That would be right here. I'm going to just really lightly mark that because that point is not going to be on my final graph. And then my slope is 3. So up 1, 2, 3, and over 1. Well, that lands directly on that vertex point that we had put up initially. So, all right, and I'm going to go ahead and make another point here. So 1, 2, 3, 1. Maybe one more. 1, 2, 3, 1. Alright, now when it hits this border over here at this vertical line at x equals 4, that actually is a solid point. It's not an open point. So I'm going to go ahead and mark that one too. So up 1, 2, 3. And just to verify that I'm using the right values here, I can, let's see, this is 1, 2, 3, 4. X value of 4, and then 1, 2, 3, 4, 5, y value of 5. So if you want to make sure, you could always plug in that x value of 4 and see if you get a y value of 5. So 3 times x value of 4, that's 12 minus 7, which is 5. So we did graph it correctly. There are a lot of ways that we can check our work in algebra. So as I said, this line is only going to be in this small range right through here, okay? Because once we go past this x value of 4, we're going to have this absolute value function. I'm going to go ahead and graph that line. Sometimes you'll notice when we're sketching these, I might kind of continue the line over there just lightly, and you can barely even see it on the recording. I'll erase all of that when we're finished, so just like that. Okay. Now one more function to graph here, and it's an absolute value function. That was way back in Unit 1, so if you need a little refresher on the absolute value functions, what we do, we take this portion inside the absolute value bars and set it equal to 0, and then just solve for x. That gives us our x coordinate of our vertex. And if we plug that x coordinate of our vertex back in to the function, we can get our y coordinate, which of course the interior here will equal 0, and you'll add 5 to it. 0 plus 5 is 5. So my vertex here, 4, 5. So I'm going to go ahead and get that vertex graphed at 4, 5, and you'll notice it happens to match up identically to the point that we had already had here on our linear function. So it's this point. Okay. And then, like I said, we're not using any values over here for the absolute value function. So I would just want maybe a couple points to the right just to get an idea of where this portion of the v is going. Alright, so if I plug in 1, 2, 3, 4, plug in a 5. 5 minus 4 is 1. Absolute value of 1 is 1, and 1 plus 5 is 6. So x value of 5 gives us 1, 2, 3, 4, 5, a y value of 6. And if you want to check the 6 as well, which will give you 7. So once we get to that point, almost a continuation it looks like, but it is a little less steep as far as the slope is concerned once we continue on past that value. Okay, just like that. So that would be my complete piecewise function for this. This is what's called a continuous piecewise function. You'll notice that all of it is connected here. All of it is connected. Now I'm also going to show you how to enter that into Geogebra, which is a little bit difficult as far as what you have to enter in here. So I'm down here in my input bar on the lower left, and I'm just going to go ahead and enter here f of x, just means the function of x, equals, and now I've got to put all these conditions in for a piecewise function. So in our particular case, we're going to do the conditions. X is less than or equal to 1. I'm going to write if first, sorry. if, and then you're going to have to put an opening bracket. Now you'll notice when I put my opening bracket in, the closed bracket already pops up. All the brackets have to be 100% perfect. I'm not going to enter any spaces. I'm going to enter my condition x less than or equal to 1. You'll notice that I typed in the less than sign and then equal to 1. You can also get your less than or equal to sign over here, by the way. If you pop that up, it'll have less than or equal to, greater than or equal to. Alright, so after x is less than or equal to 1, which is my condition, I need to put a comma, and then I'm going to put the function. So we're always going to enter the condition, comma, then the function. So in this case, the function is negative, open parenthesis, x minus 1, close parenthesis, squared, so I use caret 2. Alright, and then minus 4. Now I'm going to put another comma. The commas are crucial. If you don't have everything entered perfectly, then you're just going to get an error when you try to tell it to graph this. So it's very important that you have the commas, the brackets, everything has to be perfect. Our next condition is if, and then open your bracket. Okay, 1 is less than, x is less than or equal to 4, comma, and then my function, which in this case was the linear, 3x minus 7, and then another comma, and then another condition is coming, so we have to type if again. If, open bracket, and then in this case it's x greater than 4, comma, and then we have to use absolute value bars here, but for the purposes of GeoGebra, you're just going to type ABS, and then whatever's in the absolute value bars you have to put in a set of parentheses. So I put ABS, open parenthesis, and then x minus 4 is inside the absolute value bars. Now I've got to go outside of the parentheses. I'm just hitting my arrow key once to the right, and then we've got plus 5. Alright, now you'll notice we want to make sure the brackets are perfect. I had 1, 2, 3 open brackets, so I have to make sure I have 3 closing brackets down there, which I do. And then I'll hit enter, and you'll see that it'll graph our piecewise function. We have a part of a parabola here, then we have a very steep line, and then we just have the right half of an absolute value function, and it does list everything here exactly what we had on our hand-drawn graph. And if you'll notice, it's just like our graph here. Okay. All right, now let's work on this second function here. And this one again has quite a few conditions. Again, you might have a different technique that you like to use. I like to kind of just put a general sketch of my borders here. So less than -4. So -1, 2, 3, 4. This is just, like I said, I'm sketching it very lightly. You can barely see it. That way I know where to stop that. All right. Now, between 4 and 2, or between -4 and +2, rather. So that's way over here. I'm going to go ahead and mark that border as well. Then the last condition that you see there is x is greater than 2. That's for this quadratic down at the bottom. All right, so -2x. Some of these are a little trickier, and I'm going to do this all in my regular pencil here, but some of these are trickier because if I'm graphing the graph of -2x, well, this is a linear, but the y-intercept is 0. So it crosses at the origin, but I'm only graphing that line over here on the, to the left of this -4 border. All right, so -2x. I'm just going to sketch these really lightly because I'm only graphing the portion way over here. So the origin is here, but look what happens if I do -1, 2, and then run 1, then I'm giving points over here to the right. So for this -2 slope, I'm going to actually rise positive and then run negative. Now I'm not going to make a very dark point because that's not going to be in the final portion of this graph. It's only going to be on the left of that -4 border there. So same thing, rise 2, run -1, rise 1, 2, run -1. So I've got some points plotted out here. And keep in mind, I'm only going to graph the line on the other side of this border. All right, so just like that. All right, I'll put a little arrow at the top. Now, it's x is less than -4. Less than -4. So this value of -4 is actually not a part of this particular linear function. So I'm going to put a nice open circle there. I'm going to erase these other points that I plotted in. It's another good tip. It really helps to have a good eraser when you're doing the piecewise functions. Okay? Now, f of x is 1 if we're dealing with a domain, x values, between and including -4 and +2. So in this entire portion in the middle, it's function of x equals 1. You might remember from Unit 1, function of x equals 1 is the same as y equals 1. Well, that's simply a horizontal line. All right, and it does include this point. All of our y values are 1, so all we have to do is draw a horizontal line here. It also includes this point. Now, I'm just going to draw a solid horizontal line between those points. Now, you're probably already noticing something much different between this line and the last line. The big difference is this line is not continuous. So this is what is called a discontinuous piecewise function. All right? In other words, they're not connected here. This is way up here and this is way down here. Okay. All right, for our last portion, x squared minus 4x plus 7. Well, you might remember there's a couple things we can do here. We could find our axis of symmetry using this formula. X equals negative b over 2a. Well, let's see, what is our a, b, and c here? We don't really need the c, but a is 1, b is -4, c is 7. Okay, well, let's go ahead and plug those values in. X equals negative, b is negative 4, over 2a is just 1. X equals, careful with your signs here, okay? This is just negative 4 over 2, which is negative 2, but don't forget this negative value on the outside. So now that's our x-coordinate of our vertex, and it's also the equation of our axis of symmetry. All right, well, ironically, that's right here at x equals 2. So we know that's our vertex. So I only really need to plug in x values of maybe 3 and 4. I also want to go ahead and plug in my x value of the axis of symmetry just to see what the y value is here. So we can plug that into this, or for me, I would probably go ahead and complete the square and get this a little easier format to work with, but we could go ahead and just plug the 2 in there. So 2 squared is 4, minus 4 times 2, which is 8. So 4 minus 8, that's negative 4 plus 7. Well, that's 3. So 2 comma 3 is going to be my actual point there. So let's see where that is. 1, 2, and then up 1, 2, 3. But remember, this is already included at the end of that horizontal line. So this is again going to be an open circle. All right, and we're going to go over the process of showing these open circles in GeoGebra as well. All right, so next thing we'd want to do is just plug in this x value of 3 into that quadratic. When you plug that x value of 3 into the quadratic, you're going to get a y value of 4. When you plug in the x value of 4 into that quadratic, let me see what you'll get. 16 minus 16 plus 7, so you'll just get 7 up. 1, 2, 3, 4, 5, 6, 7. Alright, so that, continuing from the open circle, is going to be a parabola. It's going to go steeply up to the right there. Not the prettiest parabola line I've ever drawn, but that will do the trick. Now let's go ahead and enter all of this into our GeoGebra. I'm going to go ahead and delete this other function, so we'll be looking kind of at a fresh screen here. Alright, same thing. F, open parenthesis, x. Notice I already put the close parenthesis in there for me. Okay, equals, and now I've got to start with my conditions. If x is less than, I'm going to put my bracket first, x is less than negative 4, comma, negative 2x. Remember, condition and then function. Do not forget the commas. The commas are critical here. Comma. So next condition, if, opening bracket, negative 4 is less than or equal to x is less than or equal to 2, comma, 1. Remember, our function there was just function of x equals 1, or y equals 1. That was that little bit of a horizontal line. Comma, next condition, if, opening bracket, x is greater than 2, comma, we have x squared minus 4x plus 7. Alright, check to make sure I have all my closing brackets that I need, and I do. And then just hit enter, and then it's going to put that in there for us. Now, remember our graph. Let's look again at our hand-drawn graph. Well, we had all these open circles and closed circles. Well, let's go ahead. We're going to want those on this graph as well. Now, the two solid circles, all right, we're at the ends of this horizontal line. This capital A with the blue dot, this is where we add new points. Now, I don't want to put the point directly on the function. I'm going to put it kind of close to it so it's a freestanding object. And then I'm going to have to zoom way in here. And I'm going to try to put it right on that point because that coordinates, remember, were -4 and comma 1. And I'm going to right click the point, go to Object Properties, and I want this to show value. Value meaning it's going to show the definition there, which are the coordinates. And you can change the color of the points if you'd like. I leave them all the same color. Right, now you'll notice that it lists the actual coordinates there. I'm going to put another point down here at the end. Just drag that over to be right at that 2, 1. And then right click. And let's go ahead and show the value there too. And some of you might be watching and thinking, well, hold on a second. Once we right click it, once we right click that point, you see you have the show label, show object. You have some different kind of shortcut options there, but none of them will let us change it from show label to show value or definition. Okay. Alright, so let's go ahead and zoom back out. Now we need some open circles. Well, how do we do open circles? Well, similar to the way we do our solid circles. Same thing. We go to New Point. I'm going to try to put it right there, -4, 8. Perfect. Alright, but this one I need to be an open circle. So right click, Object Properties. I still want it to show the value, but over here where it says Style, I can change it from a solid point to an open circle. I'm going to make this one a little larger too. Okay. So now you'll see it's an open circle and it has the coordinates. Alright, let's zoom back out here. One more point. I need an open circle at the very end of this half of a parabola that we've graphed. So I'm going to zoom in pretty close to it, hit New Point, and that one just went right into place for me. That was nice. Alright, Object Properties. Make it a little larger, make it open, and then also make it show the value here, those coordinates. Alright, and let me go move this. I want to center it really well. There's some pretty neat things you can do as well. I can drag the name of this function down here, or I can actually click the function itself here and go to Object Properties and say I want to show the definition. But the problem there is if you show the definition, it shows all those entries that you put in. I'll show you what I mean here. So it's going to pop up on the screen in a moment here. See up there? It kind of lists the way we entered the conditions, okay? Which that, I don't really care for that. So, alright, we can also just grab this highlighted function here and just drag it right onto the graph. Now you'll notice some strange looking symbols there, but at least it does list the functions here for you. Okay. Now we can also go to the object properties of that, and let's say you wanted to maybe change that background color so it'd be a little more visible. Let's change it to fluorescent green. Then you can see that the actual label there is a little more visible. Alright, I'm going to zoom out a bit here, resituate this. Now if we need to get this in a Word document to submit it for grading, that's not too difficult. We just go to File and then Export, and then we go to Graphics View to Clipboard. I'll show you that process once again. File, Export, Graphics View to Clipboard. I'm going to click that, and that's going to save that graph to my clipboard. And now we'll just need to open up our Word document here. Alright, so I'm in my Word document, and depending on the version of Word you have, most of them will have a paste option here. You can also use the shortcut. You can see it says paste. You could use Control V. I'm just going to click on the paste button here, but if this were number 1, for example, I'd want to put 1 period, first, and then go ahead and paste that graph. You can see we have the entire graph there, and it looks like the points are showing up pretty legible too. So, alright, and that'll do it for this fairly long lesson actually on the piecewise functions. I hope this helps.